Suppose you conduct a random sample of 36 Boston men. Find the sample mean weight of 198 pounds. Use the traditional approach to test the claim that the mean weight of Boston men is 185, given the population standard deviation is 40. Use 5% level of significance. So we start off by stating the null hypothesis, which is that the mean weight is 185. The alternative is still that it's different. What's different in this problem is we're asked to use a traditional approach, meaning we're going to compare t or z-scores with critical values as opposed to comparing probabilities. So first we should really verify that well, n is greater than or equal to 36, and that since the standard deviation is known and it's 40, that we're going to be looking at z. So we go and draw our z distribution, and what we're going to look for is, since we have a two-tailed test, we're going to look for the z values, more specifically the critical values, for which you get a level of significance 0.05. In other words, you would actually end up getting half of the 0.05, 0.025 here, 0.025 here. The complement of 5, which is 0.95, in the middle. So we're going to start off by finding these two critical values. So I like looking up the 0.95 on our shortcut. So doing so, we find 1.96 to be our criticals. So we get negative 1.96 on the left, positive 1.96 on the right. And now what we're going to do is take our test statistic 198 and transfer that into a z-score. And we know just how to do this. It's 198 minus 185 divided by the standard deviation, which is 40, and divided by the square root of n, which is 36. So we crunch this through on our calculator, and our test statistic comes out to be 1.95. Now, instead of looking at the probability on our z-table, we're actually already done. You see, the z value that we get is not inside of these two tails that we have called the critical regions. So we have two critical regions, or CR, and the other CR on the other side. And we make our decision that we do not reject the null hypothesis because the test statistic is not within the critical regions. 1.95 actually lands right here. So, since the test statistic, TS, test statistic, is not in the critical region CR, we do not reject H0.